Welcome to the Advanced Software Architecture course. My name is Michel Chaudron and this is the lecture Documenting in UML Part 4. The focus of this part is on modeling the behavior of software systems. In this lecture, we will present sequence, state and activity diagrams that are used for representing the behavior view. Sequence diagrams in UML show how objects interact with each other, including the order in which those interactions occur. Sequence diagrams are used to model typical usage scenarios. Sequence diagrams illustrate typical flows of how use cases are realized. The focus of sequence diagrams is always on the typical scenarios of the use case, although it is also possible to model exceptions. Sequence diagrams can be used to model the logic of a complex algorithm or protocol. For example, through sequence diagrams, one can illustrate the order of actions of an algorithm or the order of exchange of messages in some protocol. And sequence diagrams can also illustrate aspects of security and aspects of synchronization. A sequence diagram shows the interactions between a set of actors of the system. These actors can be components of the system, external systems, or human actors. These actors are depicted in a row at the top of the diagram. The units of the system for which these sequence diagrams illustrate behavior are object instances. Object instances are shown as rectangles, and human actors are shown as stickmen. The name of an object can be placed inside a rectangle or below the stickmen. In order to clarify the type of an instance, the type name is sometimes shown as a postfix to the instance name. Each of the actors has a lifeline. This lifeline is shown as a dashed vertical line that extends downward from the rectangle that represents the actor. The lifeline denotes a flow of time from the top to the bottom of the diagram. Interactions between actors are shown via messages. A message going from an object A to an object B is shown as an arrow going from the lifeline of object A to the lifeline of object B. The name of the message can be placed above the arrow. Subsequent messages are then added to the diagram slightly lower to the previous message. The period during which an object is active can be shown through rectangles on top of the lifeline of an object. This box or rectangle showing the activity is called activation timeline. Sequence diagrams can be used both in the analysis and in the design stage of development. When used in the design, a message that is sent from A to B typically represents a method call from object A to object B. Method calls can be followed by a return message, which is shown as a dashed line in the opposite direction, but often these are omitted. In the full syntax of sequence diagrams, there are many more features for richer modeling of interactions. But rather than explaining these in the video, we refer you to the lecture in the textbook. State diagrams are also known as state machine diagram, state transition diagram, or state machines. UML state machine diagrams depict the various states that one component may be in, as well as the transitions between its states. The purpose of the state diagram is to model the dynamic behavior of components. State diagrams define the different states of a component and how a component progresses or transits through a series of states when certain events happen. Such models explain how a component can show different behavior depending on the state where the component is in. Typical applications where the modeling of state-based behavior is important are embedded devices, network protocols, or the navigation through user interfaces. This slide will present an example of a state diagram for a class called item. This class represents things that can be bought in a web shop. While a user is shopping, the class item can progress through different states. It is useful to model initial states and final states. An initial state, also called a creation state, is the one that an object is in when it is created, whereas a final state is the state in which the behavior of a component ends. States are represented by rounded rectangles, and transitions are arrows. And they show the progression from one state to another, and such transitions can be triggered by an event or action that is either internal or external to the object. Activity diagrams are targeted at capturing entire workflows or processes from start to finish. In doing so, the diagrams show the many tasks and decision points that exist along the process. An activity diagram is drawn as a graph of tasks, decisions, and synchronization points. The flow through this graph can be concurrent, including branching and synchronization, illustrating that tasks can happen at the same time. Because of its possibility to explicitly describe parallel events, activity diagrams are well suited for the illustration of business processes, because business processes rarely occur in a linear manner and often exhibit such parallelism. Activity diagrams are similar to flowcharts in the sense that they can also represent complex decision procedures. Activity diagrams are constructed from a limited number of shapes and are connected by arrows. The most important shapes are a black circle representing the start or initial state of a workflow. Rounded rectangles represent actions or tasks. Diamonds represent decisions. Bars represent the start, split, or an ending, a join, of concurrent activities. Arrows denote transitions. And an encircled black circle represents the end or final state of a process. The lecture documenting software architectures with views in UML, part 4 on behavior modeling is now finished. Thanks for watching. See you next time.